Team update, our first official update of 2018. I thank you for helping me with my IT problem. I'm a steam locomotive guy. We'll talk air brakes and staples all day long, but as many times as I set up a PowerPoint projector, every now and then I need help. So thank you very much, sir. Well, I want to start out by introducing some very important people in my life and our crew. My wife, Nancy, she puts up with my train life. We call it our train life. Saturdays and Sundays, Monday through Friday, we pretty much spend our life working on locomotives and train things. And that comes from a childhood interest in trains that I got from my father, Ed Sr. Many years ago, when we were young, Dad would take us along the track, and of all things, we would watch the 8444 back then go by. For a young person, 5, 6 years old, it was terrifying, but something happened, it did something to me. And I never thought that I would have an opportunity to work on big steam locomotives. Not to mention the 844. So thanks, Dad, for all you did and all the stuff. We'd go on travel trips like a lot of families. Anytime there was a train, my dad would make a certain sound, and that would alert me in the back seat. And I would be like a puppy dog looking out the window, trying to find, where's the train? Telephone poles, fence lines, anything that resembled a railroad track had my immediate attention. Struggled in school a little bit because school didn't pertain to railroading that much. But I'm really thankful for my great family and great friends. And here with me today we have Ted Schulte. Ted's been with the program, been with me. I've known him since I was 17. He and I met years ago. And Ted and I had an opportunity to work. I was working part-time at the Georgetown Loop in the 1990s. And he came up and rode up and down the track a couple of times with me on one of the oil burners, the 12 and the 14, a couple of the big oil burning shays up there. And after watching us do it for a time or two, I said, why don't you have a crack at it? Well, if you know Ted, Ted is one of the best, I would say the best machine operators I've ever known. He has a natural ability and a natural skill for machinery. Understands it. It's just a gift that he has. So he did it, and within minutes, you wouldn't know that he hadn't done it all his life. Well, back when I began my current role as manager of the steam program, regrettably, we went through a pretty tough transition where we lost some pretty key people. Lynn Nystrom passed away just a month before I took over as manager. We had another individual that was nearing retirement. He was a conductor, was not an engineer, and he didn't want to be an engineer. I found myself needing people. So I remembered that time in 1990. I invited Ted up. We were just getting the Lynn Nystrom funeral special, the 3985. We decorated it with Lynn's favorite colors. If anyone knew Lynn Nystrom, he liked chartreuse, kind of a purple color. So we put that on the locomotive and took it out for a test run. We made one trip up what we call P1 right by the depot. And I told Ted, okay, your turn. And he didn't want to. This is the 3985, a big superpower 4664, 280-pound pressure, 535 tons. He just climbed on it a few days before. I'll back up the story real quick. When he got there, the day that I called him and asked him to come up and work with me, he showed up later in the day and I handed him a booklet. As a matter of fact, this is the book that I handed him. The Alesco instruction manual for the exhaust steam injector. And I said, you're going to need to know how to work that thing. Take it home and read it. So he gets over there and he didn't want to do it. He wanted to watch. Well, everybody wants to watch. And I want you to fire this locomotive. And you remember what you told me? He didn't want to. So I said, sit down and do it. You'll be fine. And no exaggeration, by the time we went by the depot, the stack was clear and the safety valve was lifting. And I went, yeah. And so we worked together for the several months, he and I on the locomotive, and I was showing him all the little tips and all the little tricks. As a locomotive engineer, you want a good fireman, and you need to have a good locomotive fireman, somebody that could really do a good job for you, because you've got your hands full running the locomotive. These big superpower engines, and if you're into steam locomotives, you want to see them run correctly, you want to see them handled properly, you want to see them fired correctly, not a bunch of smoke and a bunch of amateur stuff going on that eventually can damage the locomotive and make your life really hard. So we've worked together for a long time. I'd also like to introduce Jimmy Thompson, who's one of the newer members of our team. Jimmy's an outstanding welder. People often ask, how do you get people to work for the steam crew? How do you hire people? We give a lot of tours all the time, and it's only natural when you're looking around a big locomotive shop that you would expect to see the older generation working on machines and making parts. And here you got guys, Jimmy's 26, as old as my daughter, and Garland is younger as well. Our foreman, Austin, who couldn't make it today, he's helping his father move. He's 30, and he's the foreman of the crew. The foreman runs the crew, so he's responsible for laying out the work. And not only can he do that good, but he can make great parts. He's a great welder and a great machinist in his own right. So that's how we get people that are passionate and really care about steam locomotives and want to do a really good job and make good parts. We brought some extra parts with us today, some new and old, and I'll talk a little bit about those, but when we're done with the presentation, we'll have a little bit of time for question and answers. You can ask any question you like. It's not secret. It's not a nuclear missile program that we're in charge of, so there's nothing secretive about it. A lot of air brake parts, some old rusty stuff, tooling, and a bunch of different variety of staple tools. And then this is something you don't see every day. This is called a DB7, made by the Nathan Manufacturing Company, and it's a hydraulic oil pump. And the big boy has 4 of these. The 844 has 2. And this was rebuilt by Ted, one of Ted's many duties in the shop. He has the responsibility for working on intricate work. So without any further ado, let us start our presentation today. And once again, this is dedicated to the person in my life, my wife, that puts up with all this. And she gets to ride behind me in the cab, and she goes with me whenever we do all the traveling. It takes a lot to put a trip together. A lot of people don't understand. You just don't run a steam locomotive out of the garage and head out on the main line. There's literally weeks and weeks worth of physical planning. You have to go look at things and coordinate with people. So it's just a huge job. And here's our crew. Now this is the crew just before we departed to go on our trip to Boise. And over here on the left, if it's okay with everybody, I'll just point everybody out. On the far left is Troy Flagg. He's a electrician out of North Platte, Nebraska. He's fitting in really well with this crew. This is kind of like, I guess you could say almost like the special forces, in that you've got to do whatever you've got to do on a crew. If you're stuck into the routine that all I am is XYZ job, then we're going to have a lot of people on the crew in order to get all the work done. And realistically, we're very fortunate that we're fully funded with a staff of 9, including me. So we're very, very thankful to have everyone. And his characteristic smile, right next to him is Jimmy Thompson, who I introduced a moment ago. And Jimmy, like a lot of us on the crew, is living a dream, working on the special equipment, working on this big special locomotives, traveling around, watching all the people's reaction, and welding the boilers, and doing the heavy-duty, hardcore work that we do to keep these engines running. And just to Jimmy's left is his partner, Don Creer. Don's been with us since 2012. He joined the crew 2 days before we slid the drivers in Texas. That was Donnie's first experience with the crew. And he's an outstanding metal fabricator, and he's the second part of our 2-man certified welding team. Behind him is Donnie's close friend, Kurt Clark. Kurt is our steam locomotive fireman, and you know me here, And here's Austin Barker, Foreman General 1. I've known Austin since 2010. He was another very good find. Just one of those, literally a 1 in 1 million type of candidate that you would have come across your hiring session. And then Bruce Kirk, a tremendous tool and die maker. Bruce has a gun shop in Fort Collins. So Bruce specializes in making whatever type of tooling you can imagine. And these creations are from his mind. And he will come up and he's just relentless in his pursuit of making just the right tool. And this stuff takes a long time. It takes a long time to work on something. So this isn't a shop that you would be accustomed to like in a modern machine shop where there's heavy production, there's alarm bells ringing when it's lunchtime, you know, all this really heavy pressure of production. Well, as you know, we want to have this locomotive done, so we do have the pressure on us, but we don't want to get to the point to where this place becomes a sweatshop. It's hard enough as it is. This is the crew when we got back 30 days later. Notice the smiles. Some of them aren't as big as they were, but they're still there. And that's the magnificent 844 that you see behind us. My Weimaraner helped me put this PowerPoint together, and he wanted this slide in there. That's our beloved Shadow. If anyone knows what a Weimaraner is, you can understand. They've got quite the personality. He goes with us when we make our reconnaissance trips. In one quick shot of the 844, imagine, if you will, change the number on the cab and make the cab a little bigger and the boiler a little bit longer, and that's what the 4014 is going to look like when we're finished with it. It served its life as a big utilitarian, coal-burning, 7,000 horsepower power plant. Its new life is just like the 844, a public relations ambassador for the railroad. We won't doll it up quite as much as we have this locomotive. This was a passenger locomotive. And the 844, having never been retired, has a very special place in our hearts, but in the hearts of thousands of people, I would say tens of thousands of people employed on the Union Pacific Railroad. So this is one very special locomotive. So if we put a little stainless steel nut here and there, and we keep the jacket nice and clean, and we nickel plate the throttle, and do nice things like that, that reflects the corporate pride we have in our program. And here's one more quick shot of the 844. Look at how massive that locomotive is. For those of you that aren't really familiar with the Big Boy Locomotive, I'm going to refer to the drawing back here. And this is the 844 right here, if you cut it off about right here. And you take this four-wheel engine truck and you put it here. Well, look at what we have. You've got a 4884. The boiler pressure is still 300 psi. The valve dimensions are nearly identical. A key difference is the cylinder dimensions are a little bit less, or a little bit more than an inch smaller in diameter, and the drivers are 68 inches versus 80. So look at the massive machine that the Union Pacific needed to do a job. Imagine what that will look like. I have the good fortune of operating, running, and firing the Challenger a lot, and that's a big locomotive. The Challenger, it's kind of like a sports car in a way, that it responds quickly, being articulated, it's nice and flexible. You can see why they like to use them on passenger trains. That small wheel accelerates quick, and just a really fascinating engine. And of course, the sound of an articulated is something I won't simulate it for you. I often like to make sound effects. But the sound of a steam locomotive is something that it gets in your mind. And maybe that was the thing that really got me into steam locomotives, was the whistle and the sound they made. Being of a different generation that had never seen steam locomotives operating, I couldn't relate to them like the generation that saw them. But there's something about the steam locomotive that's just fascinating. This is a picture I took yesterday morning. We've got some lights set up in the firebox. I'm not going to go into too much detail on the boiler work because we kind of like to keep some of that stuff fresh, because we've got some really neat boiler work that we're doing. But for those of you that are familiar with the nomenclature of a steam engine, you'll know what that reflection or that shadow is, which means we've got the rear tube sheet in already. And we're making revolutions to do some big rivet work that I'll talk about, and then get the front tube sheet in, and then the tubes are going in, and then the superheaters, and it's just step by step, just like we did on the 844. Here's a drawing that I bring with me a lot. This is how we make our new tools and our new materials. We take the Flannery drawings that I have up here, and we redraw them in CAD, and we send them to these various suppliers that are set up to make bolts and to make forgings for us. So we don't have to do the forging at the shop. We can send it to a shop that can give us the right certified materials and processes, and we get the bolts back, and all we have to do is cut threads on them. I'm sorry you can't see the detail on that too much, but this is what's called the boiler detail drawing for the official Union Pacific drawings. And this is the Flannery staple system, if you will. And these are all the different types of staples that you'll see on the big three superpower classes, the 844, the 800s, the Challengers, and the 4000s. The 800 utilizes a lot of this style of arrangement, where you have a sleeve that's welded on the outer sheet, and then a cap that covers that seals that up. On a big boy, because they were so big, they couldn't afford that extra little dimension there from a clearance standpoint, and that was one of the reasons that the 4000 have the MKS style, and I've got some of those up here to show you when we're done talking. This is Bruce working on some stay-bolt taps, getting those all sharpened up. We're right around 500 stay-bolts that we're going to replace in the 4000. Which isn't much when you know how many staples the thing has. But we've got to do some sheet repair work, and in order to do that, those staples come out. Locomotive being a coal burner, every 3 hours or so, when that locomotive was in maximum power production, you had to put 28 tons of coal in that. So for a 3 to 4 hour period, you were blowing 28 tons of coal through the stoker onto the grates. Some of it didn't stay on the grates long. And then it went up over the brick arch and through the tube sheet and out the stack. And coal, when it burns down, as you know, those of you that have ridden behind a coal burning steam locomotive, a pretty good size, almost like a bacon bit. And it's really abrasive, like a little glowing piece of pumice. And as that thing is flowing through the firebox at tremendous velocity, it's wearing down the metal that it comes into contact with. So the UP and a lot of railroads welded what they called eyebrows on the leading edge of all the staples, so that abrasive effect of the cinder flow wouldn't erode the staple head away, and you were constantly having to replace the staples, not because they were breaking, because of cinder erosion. On an oil burning locomotive, we won't have that. Here's another set of tools that Bruce has made that I brought with me here. And they are to prepare the cap surface on this type of staple arrangement in a cutter, so you get the correct relationship between the cap and the sleeve so it seals. You've got, in some cases, thousands of those caps, and when you go to hydro the locomotive, you could have a real mess on your hands if you didn't get that part of the process right. You're going to have a lot of leakage. So, for example, when we did the hydro, that's what this drum head here is for. On the 844, we had very little leakage. We're talking a little drip here, a little drip there. Because when you hydro a locomotive, the regulation says no leaks. What does that mean? Are we going to look the other way if we got a stream of water here? If there's water drizzling out of the cylinder cocks, if there's water shooting out of the turret, you can't have any leaks. So I take that really serious, we do. So when we put the boiler together, it's tight. The other reason you want that is when we travel with the steam locomotive, we take it out on trips with us, and there are times when we're going to be out close to 40 days. Well, by federal regulation, we are only given 31 service days before we have to wash the boiler. We may not have to wash the boiler in that 40-day period. So what we want to do is we don't want to steam the engine up or have a fire in it for a 24-hour period and we gain a service day on the calendar. And that's how we're able to stay in the field for a long time. If your locomotive leaks here, leaks there, you're not going to be able to do that. It's going to be out of water and out of pressure, and you won't be able to go that 24-hour period. So all of this plays into a big strategy. This is another tool that's come in really handy on the 4000. This is called an MKS cap cutter, and Bruce made this. It's pretty heavy. It's got 6 cobalt tool inserts in here, and it's designed to cut off the MKS, pardon me for getting in your way here, and it cuts the weld off of that cap that I showed you a moment ago that's welded on top of that staple. So it's not as destructive as using a torch. Sometimes we use a plasma, or excuse me, an air arc. That's a really quick way of getting them off. But you got to be really careful with that arc that you don't gouge into the boiler when you're cutting that cap off. And here's literally dozens and dozens of the big long radial staples. I've got one up here. The radial stays are up on top if you're familiar with the layout of a steam locomotive, the cross section. Looking at the firebox in here, your crown sheet is right here. You can see when you come up, you'll be able to see it. This is the crown sheet. Well, it's stayed along the side in stay bolts that are a little bit shorter, and they get longer and longer as they get up toward the top. When they get up around the top, those stay bolts begin to arch over in a radial pattern all the way up to the roof sheet, and they go down and they connect at very close intervals called a pitch to that crown sheet. Well, the radial stays, being very long, and they're flexible with the ball on one end, there's a lot of movement in a big locomotive firebox. So we're replacing a lot of those radial stays. When the Union Pacific changed out the tube sheets on these engines, they took out the first row customarily. And because they were doing that almost on an annual basis, they made the first row of staples the sleeve type, so you didn't have to cut those caps off. Well, we're going to go back and we're going to make it back to the MKS type. And here's a little bit smaller, flexible type KJ staple. Is this too technical and too boring? No? My bosses, when we talk about stuff like this, their eyes glaze over when I start talking KJ and Flannery and Ilesco. Well, these are made on one of the lathes that we've rebuilt in our steam shop. A couple years ago, it was the worst example of all the machine tools in the shop. It was just filthy, cruded up, didn't run, and it looked terrible. Well, we wanted to use it to to roll the threads on our stay bolts, and when you come up afterwards, I'll show you those stay bolts here. It does a really beautiful job cutting the threads on the stay bolt. Garland, our machinist, he's one of my 2 machinists. He takes great pride in his workmanship, and he goes to the trouble of putting thread protector sleeves on each bolt. I love that. A lot of pride. Now this is some of Jimmy's handiwork. This is a close-up of that MKS cap welded on the stay bolt, just adjacent to it. Some of the caps sat up on the top of the locomotive. When the locomotive sat in California, the reason I wanted the 4014 over all the other big boys is for this reason. It had less corrosion and it was less worn out. Some of the machinery on other locomotives were a little bit better, but on balance, the boiler was in the best condition. When you're talking about a big 300-pound pressure vessel, look at the size of this thing. You want to have 100% of that boiler in the best condition you can make it. You're going to have a little corrosion here and there around the safety valves. Pine needles for 5 decades were raining down on parts of the boiler. down here along the cab where this brace is here. We've got to cut that out because it's wasted very, very thin. But on balance, the engine's in really good shape. This is one of the areas that's a little bit more corroded. But when you clean it up and you take and you analyze the thickness, make sure it meets the minimum standard, and then some, you're left with a cap that's only 3/16 of an inch thick, and it's pretty well pitted. So part of Jimmy's responsibility for the last, what's it been, 2 weeks now? He goes around and he cuts off all those caps. I had a conversation with him yesterday. I said, this locomotive's gonna be yours longer than it will be mine. Because I'll be retiring here in a decade or maybe 12, 15 years. And after that, I pass the responsibilities of all of this to the next generation, which is him and Austin. So I put that responsibility on them. If you want it to be on there, that's your judgment, but I know he's going to use the good judgment, and if he's not happy with it, I won't be happy with it. So he's over there busily cutting them off. How many caps have you got off already?
Well, we got about 300 off, and I've got about 150 bolted back on.
He's got 300 off, he's got 150 back on, and there's probably going to be a dozen or so more that he'll peel off that we didn't catch on the first pass. We're not done taking all the little stuff off yet. I mean, there's little things, it doesn't quite look right, we'll get it off of there. And here's another picture of what they look like when they're a little bit more corroded. Don't let that deceive you. Some of that pitting looks worse than it is. And here's what it looks like when they're welded back on. Part of what we've been doing over the last 7 years is fixing up the shop, cleaning up the shop, fixing up tools, and getting the equipment that we need. Part of that involves, get my mouse to work here. I might have to move a little bit closer. I'll relocate over here so my computer works. Part of that involves cleaning up the area above an office-type ceiling. Not unlike this ceiling here, it was a little bit different. In 1990, it probably sounded like a good idea at the time. They installed that acoustic tile ceiling in the shop. And it probably served pretty well. It retained some of the heat in the winter months. It's a big building, it's hard to heat. Changed the lighting around a little bit. But what happened over time with all the numerous broken windows, if you've seen the steam shop, it's just a huge building. Lots of little broken windows, and our little flying friends come in and they take up residence in that shop. So from 1990 until 2013, there were 250 odd pigeons, many generations of these pigeons living up in that place. And if you look at the expanse, the massive size of that shop, it was a daunting job. I remember one time back in, I think 2005, somewhere in there, I climbed up on one of the ladders and I pushed up one of those ceiling tiles, which was a mistake. This stuff rained down on me. I stuck my head up in there and I was stunned at just the appearance of the shop, how neat it looks, how big it is. But my heart sunk because as I looked over that huge, vast area, I saw twigs and newspapers and you know what, really thick. And some of the tiles themselves were actually that the plastic coating that was up on that had failed, and some of that burnt stuff was starting to discolor and starting to bulge some of those ceiling tiles. So I knew this is a problem somebody's going to have to deal with. Well, we want to bring the shop back such that we can do the work that we need to do. Not likely going to get a 250-ton crane, that would be great. If we could have the same type of crane they had in there, that would be great. But how often do we need something that big? And that's $1.5 million. So I can spend that money on a few other things. A crane of this size is a fraction of that cost, and it can get the job that we need to do on a regular basis done. We've also bought some articulating forklifts that can do other lifting jobs for us. As you'll see in a few minutes, we've bought some other machines. This is a really neat view of the shop. This is taken from the northwest corner. And that's a 4,000 big boy boiler. When they built this shop in 1919, the biggest engine they had back then easily fit in that bay. When they had to lift big boys, they had to cut the back of the cab off. And you could barely shoehorn the front of that smoke box, the door couldn't be open. And you'd cut the back of the cab off and you could pick that boiler up in the air. Well, tomorrow we're going to start lifting the big boy again. We're not going to pick it up as high, we're going to remove the trailing truck. And that represents the last major piece, or the last piece period, other than Jimmy's caps here and there, that we have on the big boy. Here's another shot of the crane. It's really neat to see. That picture doesn't do justice how big that crane is. And we had to shoehorn to get it in there. We had the company that built it hired a specialty construction firm, and we actually lifted each one of those pieces. They're 13,000 pounds each. We lifted those things up and hoisted them 48 feet up to that crane rail. The reason we wanted to go with the crane and put it up that high is so it gives us the headroom to make the lifts that we need to do. The lower crane rail that you can see down there was for two 20-ton cranes. Back in the days when they were rebuilding steam engines every day, you needed, I've read stories of this facility. There was an article in Railway Age magazine. The cranes were so busy they had to come up with a system of lights. So when you needed a crane, you went over to one of the bays and you turned on a light. The crane operator, when he was freed up, he would go over to you and take care of what you needed and go over to the next one. I mean, just think about that. You know, all the work that they did. Well, we don't need a set of lights to use the crane, but we use it quite a bit. It's got a 5-ton auxiliary hoist. You don't realize how much you need a crane until you have one, because you're used to doing without. You either put off a big lift and you arrange to get Holcher, or a big heavy lift, a very expensive company to come up and make your lift for you. You plan for good weather because you got to do outdoors. You can't move that stuff inside. And the whole concept of locomotive work takes on a completely different look. When you have a crane like this, one guy can put an air compressor on the engine in 10 minutes. You can hang the brake cylinders. You can do any number of things that you were doing before with a forklift, with a sling, or some other secondary way of doing it. Not that it's not safe, but sometimes in the world of a steam locomotive, when you got to lift stuff, if the safety department showed up when we were lifting some of this stuff, I would have to explain to them how we're doing this correctly and safely. They would kind of raise their eyebrow and see this air pump hanging off of a sling when we're holding it with this side of the forklift and we've got this other forklift over here. How else are you going to do it? So it's fun work. This is our track. This doesn't look like it's part of the steam shop. We built a small room, we call it our clean room, and this is a computerized lathe that we use to make lots and lots of little parts. And it makes some pretty good sized parts too. When you come up here in a moment, I'll share with you when we're done, a lot of the parts that we make. One of the projects that we started on, as we start to put the front engine together, we need all these little special hydraulic fittings or compression fittings. You can't find a compression fitting this heavy duty at any hardware store in the country. We bought some 3,000 PSI compression fittings from McMaster-Carr, MSC, you can order that stuff. It's nowhere near as heavy duty as this. This is what a steam locomotive needs. And these come in and out of these big hydraulic pressure fittings here. Well, on the steam locomotive that was built in 1941, some of these old fittings are still in good shape, but not many of them. So, like oftentimes in the project, we just take all of the good stuff, and maybe we'll sell it as a souvenir someday, and we replace it with new. So we've duplicated that fitting and made it brand new. So just like the staples and everything, we'll draw this drawing in CAD. Doesn't take that long, and then you can email that file, and we can program it into this machine, put a piece of hex stock in there, the machine goes to town, whips it out for you in a few minutes. And then before long, you've got a whole drawer of all these nice new hydraulic fittings. This is the machine this is the brother to that. This is called a Tract Mill. What the lathe can't make, the mill can. Again, it's a computerized machine, speed up production. Garland, one of my machinists, loves running this kind of equipment. You can see out the door into the steam shop. When you walk into this place, it doesn't look like the rest of the shop. And we wanted to make these rooms so we could keep the machines clean and do the really accurate work. If you've been to the steam shop, it's a dirty place. As many times as we clean it, that wind, that beautiful breeze that comes through Wyoming every now and then, brings with it tremendous amounts of sand and dust. And try as you might, that's just the way it is. And here's the nice cabinet that Ted has. Ted and Austin have gone through and they're putting all of the lube lines. As a matter of fact, we're done on the front engine, correct? So all the engine oil and all the valve oil lines are all installed on the front engine, as well as all the piping. This is the burner, and this is an example of what you can do with today's technology. So we can draw, Austin will draw each piece, and then you can assemble those, and you can also model those pieces as they fit together. You can subject them to certain stresses, you can flow volumes of liquids through them. It's just a really handy program. And I brought with us the burner for the 4014. And for those that are curious about it, it's not some big scary ominous thing. I can hold it in one hand. It's very similar to what's in the 844 and what's in the 3985. Just a quick little segue on the oil conversion on the big boy. If for some reason you did not want to run a big boy locomotive and people kept asking you, when are you going to run a big boy, what would you tend to do? You would downplay it, wouldn't you? If you didn't want to restore a big boy. And over a few decades, that downplaying would turn into, it's too big, it's too heavy, it can't turn anywhere, and it's impossible to convert to an oil burner. Well, that's worked into our advantage somewhat. That's part of what makes the Big Boy project so fascinating, is for so many years, everyone pretty much assumed they would never see one run. Like in Allegheny, the T1 project that we hear about back east. These fascinating big steam locomotives that are part of a bygone era that people never thought they would see. But it can be done again. This is part of a machining process, machining what's called a link trunnion. It holds the eccentric link. I'll show you where that's at right here. And if you get a sense, it doesn't look very big. If you've seen the 844 on YouTube, or you've happened to see the 844 or the Challenger operating in person, that link is flying back and forth. It's operated by the eccentric crank. It's where it derives its motion from the eccentric rod, and it's moving the radius rod, which through the combination lever is changing the valve events. Well, you see that thing at 60 miles an hour, and that link is just flying. I was going to bring a link with me, but they talked me out of it because it's too big. It's all we could do to get that lubricator in the truck. And my hat's off for Ted and Jimmy for being so patient with me. They spent about 30 minutes yesterday before quitting time loading all this stuff up. So this link trunnion, one of them was broken, and it very likely broke when the locomotive traveled out to California back in 1961. Who knows, maybe it was broke before that. Well, they've got 1,200,000 miles on them. So I vote for new parts, and that was the whole part of the conversation when we, on an official executive level, were talking about a big boy. We weren't just going to restore it enough to get it running. We wanted to do everything we could to make sure the railroad has the best serviceable locomotive we can, which means it's not going to be cheap, it's not going to be easy, and we're not going to be done tomorrow. So that's one of the many link trunnions that we have. And that's the link that I wanted to load up in the truck with me. Again, that picture does not do justice. It would be from one end of this table to the other, and it's a 2-man lift, maybe 3. And they're forged, they're made exactly to the specification that the drawing calls for. It's an actual forging. And then we machine them. We've got a machine shop in Denver. You don't really realize how many people are train enthusiasts until you get out in the world and you run across people. They're not a die-hard rail fan. I personally am not offended by the word foamer. I hope nobody in here is. But I don't take exception to that. I mean, if you're just an enthusiast, what is this train show? I mean, we're a bunch of people that like trains. We'll go to a car collectors convention or any number of enthusiasts, and we're all kind of the same like-minded people. Well, the guy that owns that machine shop happens to be somebody who's really into it. What does that mean for us? We're going to get really good service, and he's going to want to do exactly what we want. He wanted to laser engrave his business name on the side of that because he knows what it is. And we thought about it for a minute, but we really, it's not going to have a bunch of stickers on the side of it. So I said, how about this? How about if we make a little plaque and we'll figure out how to put it somewhere next to the valve gear. So we'll probably do that. So we precision ground the link just as you would back in the days. And then we also had to make the link block. And the link block is what is connected to the radius rod. Can't quite see the radius rod too much with all these other lines here. But it's actually a really intricate, very precision pins, tapered pins, and tapered bolts that hold all of that stuff together because of the forces. It's going back and forth. It's going this way, and then it's jerked back that way and back. It's just tremendous inertia forces and the forces that are driving the mechanism. And the valve it's moving isn't some little light little thing you put on your coffee table. We couldn't bring one of the piston valves with us. The thing is huge. So in order to keep all this stuff together, it's very precise. And we had them machine those link blocks, and we've given them 4 thousandths clearance on either side. And when you put it in there, it fits good. And the surface, the heat treating is called nitriding. So it's a mild steel. It's not any special alloy, but the surfaces that link block run in are hardened as well as the link block. And we grease this locomotive about every 100 miles or so. And so we really keep those greased up really good. By comparison, when you look at the link blocks that came out of them, they're about almost a little bit, about 5/16 of an inch bigger. That's how much worn they were. So which means they continue to grind that link out, and they have to make a new link block a little bit bigger. Every time it's shopped, a little bit bigger. It reaches a point to where these surfaces on the link are no longer really strong enough for us to want to use anymore. That's another reason why we make new parts. Same thing with this bearing fit here. This is called the link foot, and that's the link trunnion I was telling you about. So new valve gear parts, something I've always wanted to do. We're going to do this on the 844, and then if I have my way, we'll do the same thing on the 3985. I'll let you in on a little secret. Don't tell anybody. When we source these parts, I've got enough for all 3 engines. Don't tell anybody that. So that's the plan. If you're going to go to the trouble to make something, and it can be troublesome, sourcing big forgings, sourcing big parts, finding somebody that can machine it for you, not that troublesome sometimes. But if you're talking about a crosshead guide, which is as long as this table, and it weighs 1,100 pounds, it's a special forging, and when you're done machining it, it weighs 485 pounds. And all of those wear surfaces have to be precisely machined. That's not something you're going to find down the street. Luckily, we've got a Bonneville machine in Salt Lake City, has got a milling machine that the operator rides on. He sits in a little caboose cupola, and he rides along with that cutter as it's machining. And that's how it's done. These are something we've needed for a long time. Anyone take a guess at what those are? Any steam engine people want to throw a guess out there? Ted and Jimmy, you can't say anything. These are wrist pins. One of them's for the big boy, one of them's for the 844. How many think this is big boy or this is big boy? Big boy? Raise your hand for me. Big boy?
Yes.
All right. Well, you would think that the big boy would be bigger. Because the 844 is designed to operate faster, the inertia forces that the running gear, the pins, the counterweights, all the valve gear, they really had to design that stuff and make it really strong to be able to run 110 miles an hour. It's not to say that the big boy isn't as strong, but the big boy is so big, they had to really economize, and things couldn't necessarily be as big. It's not like you're taking an 844 and you're just doubling it. So certain parts are a little bit smaller. Those are wrist pins. And the wrist pin is it's really where the action is. So you've got the piston, where you're taking the power of the steam and you're converting into a mechanical energy. And that is being managed by the crosshead and the crosshead guide. That crosshead is the point where the main rod connects to that piston. And as the name implies, it's like a wrist. It doesn't completely rotate, but it flips around, just up and down, with every stroke. And that wrist pin takes a beating. And that wrist pin has to be solid tight in that crosshead. UP had a really unique method that I hadn't seen too many railroads in installing their wrist pins. Typically, it's a tapered fit, and it's fit from one side to the other. The UP involved what's called a split collar, that itself is tapered, and it engages in the outer fit. And there's a special tool that we made to seat up the first taper, and then we take the tool out, and we slide that slip collar in, and we put on that really characteristic looking nut. It looks like the Star of David. Have you seen that? That's for a locking wire. Well, that is the best system that I've come across. I've been around a lot of steam locomotives, and one of the things as an engineer you check a lot is that wrist pin. And from time to time, you'll come across them, and they'll be a little bit loose. And you want to take care of it right now. Well, we've yet to have these things loosen up on them the way they're designed. So new wrist pins, split collars. I didn't bring a picture of the nut, but they're new as well. Now this picture too doesn't do justice to how big this stuff is. These are drawbars. And again, please don't tell anybody, but the drawbars on the top are for the 844. The big drawbars down below are for the 4000. The 844 back, when I started as manager, we did an annual inspection and we found that the drawbars had been welded, and that's not permissible. So we had to swap them out, and luckily we had a spare set, and we put that spare set in. And they're working, and they're fine, but over time, like anything, there's no bushing inside of that fit. We took the drawbar bushings out. The drawbar pins were trashed. They've been welded too. So we made new drawbar pins, and we made new drawbar pin bushings, and we put it all back together again, and we're just kind of living on borrowed time. They're not new. These aren't. But what's in the 844 aren't. I don't have a picture in this presentation to show the drawbars on 4014, but it sat around for years with that stoker right above the drawbar and coal sitting up in that stoker. So every time it rained, that acidic water would just get down on the drawbars. We could probably use them. You look at, you measure it all up, probably strong enough. But it just gets to the point where, guys, let's make this stuff new. I don't know if anybody's ever had an engine intender come apart on you at 60 miles an hour, but it's not something I want to live through. So we're going to go with new parts. And again, please don't tell anybody, but the ones on the top are for the 844. Look at how big the difference between the two are. Now this is that crosshead I was telling you about. And again, this picture doesn't really show how big it is. But we've got the two halves of the crosshead together, and we're machining with brand new reamers and making the bolts that hold the crosshead together. Now we're going to get in some really fun boiler work. And this is forming up a mud ring patch. And this is a special tool that we bought. It's a cutter that you can take inside the boiler if you needed to. And we have special made, these are custom cutters that they've made for us. And we've made up this little setup. Ted, was this your project or was this Kurt's? See what I mean by everybody does certain parts of the project. So we've made a small fixture down below. And this cutter is actually designed to fit in the end of a pipe or a tube, a boiler tube. And it bevels, it makes a nice weld bevel for you. Well, we've modified it so we can make these fits, which is the countersunk hole for the rivet that's going to go in that. Relocate my mouse over here. So we formed that plate of steel. We formed that in our press brake. You can kind of see it looks like it's got some zebra stripes on it. Each one of those is a bend line. So we have a big press brake in the shop, and we just systematically do a little bit of math, and we lay out each one of those bends. And what we have, when we're ready, it fits into this piece. You've got that piece cut out because it's all worn out. And then we clean up these holes. Some of the holes are a little bit gnarly looking. So Jimmy and Donnie will get in there and weld them back up again. Get in there with a nice reamer, clean them all up. And then we fit the next piece up in there. This is the water space when the patch of the boiler is cut out. And you can see we've been doing some grinding, some cutting, so we've got some debris down in here. This is the mud ring, or what's called a foundation ring. And these are the back sides of the big rivet seam as we transition from the back head around to the wrapper sheet. And these are flexible staple holes that you see. And they walk right up that rivet line, all the way up. And here's a flexible staple coming through. And you can see that this hole in the sheet allows, bearing in mind that that's about 1.5 inches of thickness there, so that flexible staple can accommodate a little bit of movement. Down next to the mud ring, this plate isn't going to move that much. It sits behind refractory, but it will get hot and expand and contract. The higher up the sheet you go where it's exposed to the hot 2,000-degree gases of the fire, the expansion and contraction is going to cause those sheets to move. And we have to accommodate that, and it's done through the Flannery KJ head staple. Tremendous design. But this weld fit right here, again, the picture doesn't do it justice, but this is a very precision fit. How many degrees is that, Jimmy? 37.5. You sure it's not 39? I love it. And here we are with that piece fit in there. And we fit it in there with what are called fit bolts. And the fit bolts represent a rivet. And so we get it all fit up in there, because oftentimes you're going to take it out, make an adjustment, put it back in, and there's a lot of back and forth to get it hand fit. When you get that fit up in there just right, you want that to fit very precisely, because when you go to weld it together, this will outlive me. This is going to be in there a long, long time. So we want it to be 100% rock solid. We've got it welded in, and we'll take those fit bolts out, and we'll preheat everything up, and it's a team effort. It takes all of us to do riveting, and we get ourselves set up, and we start putting the hot rivets in. It's one of Ted's favorite jobs. Here's a close-up of that fit. Real nice precision machining, and that formed head that you form on that 1,800-degree rivet that you put in that hole and you hit with what's called a 90 gun, a really big pneumatic hammer, and it forms that rivet. And you've got just seconds to get that job done before that rivet cools too much. You don't want to drive on a rivet if it gets below 1,300 degrees. You could potentially damage it. Here in a moment, when we're done, I'd like to introduce Dick Stone. He's a mechanical engineer. He works with us, and he's done the Form 4. It's the regulatory work on the UP steam locomotives for a lot of years. So Dick's a great engineering resource for us. 1,300, right, Dick? Here's another shot of that fit up. How are we doing on time, honey? Okay. This is the outside. We were looking at the inside a moment ago. Now this is the outside, and you can see a small little ring around each one of these rivet holes, and that was where the rivet was caulked. And that's a process. I brought some caulking tools with us, where you actually use a small pneumatic hammer and you seal. that rivet. Once you install it, you caulk it. And what it does, this is low carbon steel, so it's pretty soft. So you take that tool and you walk right around the outside of that, and it forms the two metal together, and it forms a watertight, steam-tight, nice seal. It'll last a long time. And there's one of the flexible stay bolts we pulled out, just to kind of illustrate how it fits in there. Looking at where the tube sheet goes up toward the front of the boiler, you can see the tube sheet braces and everything. We've yet to descale everything. This picture was taken some time back. And we have a very thin tube sheet template. So we'll draw the tube sheets up just like the blueprint shows us, and then we'll send that file over to Puma Steel there in Cheyenne, another great one of our partners, and they will laser that tube sheet profile into a really thin, easy to handle piece of steel. And then we can fit those tube sheet templates up and verify everything's right. And we've actually caught a few little mathematical errors or a few little problems here and there. And if we would have went ahead and sent that file off and taken our expensive piece of boilerplate, we would end up having to replace it. So this is a really good process of fitting up your sheets. This is the outside of the boiler, and you can see all the different markings as we're going through and fixing up the fit around here where those caps are welded on. And these are all flexible stay bolt holes. Washout plug there, MKS cap. And you can see the stay bolts that we've got removed because we're taking patches on the inside of the boiler and we're replacing, or some of those stay bolts were just not good enough and we yanked them out of there. There's those eyebrows I told you about. The Challenger has those as well. All the big UP coal burners had them, and that was out of necessity to keep those stay bolt heads alive. And you can see this one here, you can actually see and look at how it's worn down. And there was one that actually broke off and they welded another one on there. So when that eyebrow breaks off, that head erodes down to nothing. And you need to have enough material on there. We don't have to take all the stay bolts out, but it has to have enough material for us to form it. So we'll rework each one of those just a little bit. We call it touching them up. If there's not enough material for us to move around and to give it another profile, because we'll seal weld around that as well. If it doesn't have enough head material, bolt's got to come out. And this is what kills a lot of big steam locomotive projects. You climb into a boiler, in my judgment, you should not approach it from, I think it'll be okay. In my judgment, that's the wrong approach. In my judgment, you approach it from, we've got to make this thing rock solid 100%, which means it's subjected to the hydrostatic pressure beyond the maximum allowable working pressure, and you're going to climb in there and you're going to tap each one of those bolts. If something fails, you're just going to take a warm shower. If it fails at 300 psi, we won't be with you, and others could be hurt. There was a very serious accident with the 844 in 1999 in Sacramento, and it suffered a tube loss of 10 tubes. And that was a big warning, wake-up call. And that illustrated various practices had over the years slowly lapsed. Water treatment and tube installation. So we have to approach everything we do and make sure we're doing it right. I brought with me too, it's kind of a collection of the old books and the old practices. This is section 3. Boilers of locomotives, 1952, a lot of really good information in there. The Flannery stay bolt, you can get this on the internet. There's amazing things out on the internet today. And then some other neat things that we go through. This was from a test that Union Pacific conducted on how stay bolts were installed and the best way to install them. And they conducted a lot of tests on different locomotives. They assigned certain locomotives to be a part of the test, and they would equip it with that particular method of installation, and they put it in surface. And then they would do another test on another locomotive and so on, and they would see in actual field performance how well they did. Then they would go and they would actually take the plates, the boiler plate, the firebox plates, and they would subject the stay bolt to sufficient force to rip it out of the hole and to see how much force it took to rip it out of that hole. And that led to the methods that we currently use, that were adopted by the UP back in the 30s. This is a drawing that I've included before. This is another one of the stable tools that we made custom. We've got the same company with the gentleman that wanted to laser engrave his business on there. Made us these out of tool steel. These are drawn and made exactly to the UP specification. You'll find tools like this in a boiler shop oftentimes, but they'll be worn out, and it gets to the point to where it's really not giving you the performance you need, so you need to make a new tool. So that's what we've done. We've made all new boiler tools, stable forming tools. This is from my own personal collection. I keep these in my office. This is the caulking tool, and this is the stable forming tool here. All brand new. And that's what the stable looks like when you're done driving it, but you're not done yet. You'll actually walk around it with the caulking tool, and that's what the caulking tool does. It gives it that real nice formed ridge around the outside that forms the two metals into one. But you're not done yet, because you're going to subject that piece of metal and the plate that it's holding to a lot of heat. And you've formed a really small little piece of metal, very small. And over time, that fire is going to do what fire and water do to steel. It tears it up. So that fire is going to get in there, it's going to overheat that piece, and it's going to lift up a little bit. And as soon as it lifts up, the heat cannot conduct itself into the metal and therefore into the water, and it's going to get really hot. And it's going to start to fire crack, and the fire crack is just going to get more and more progressive, and it'll eventually propagate into the steel, and now you've got a bigger problem on your hand. So what you want to do is we'll get Jimmy in there. This is Jimmy's handiwork, and he's going to seal weld. And now you're physically attaching the stable to the firebox plate. So there can be no development of heat that will eventually destroy steel. This is low carbon steel. Over 1950 degrees, you start changing the steel. The characteristics of the steel are damaged. So you've got to keep it nice and cold, or cool. I don't want to say cold, but cool. So every one of those stables get that same treatment. For steam locomotive guys, that's really a nice looking picture. Here we are looking in the firebox one more time. This is before the tube sheet went in. And this gives a really good illustration of the radial staples that I was talking about a moment ago, and all the other staples. Look at how heavy duty that thing's put together. Now all of that's covered in water. Your water level is right about, I don't know if I can reach it, right about up in here. That's called your foam trough. So you've got a fire in there that's burning 7,000 horsepower worth of fuel. And that heat is conducting through all of those metal surfaces, and it's not like a little pot boiling on your stove. This is one heck of a steam power plant. That steam is really going for it in there. And here we are putting the plates together. We've got the tube sheet fit up here, and we're starting to work it in place, and we'll close this gap up in here. And here's all those stable holes, and another weld line there. And we'll start welding it all together. And there's Bruce. He just loves a challenge. So some guys would take and probably grind that by hand, and some guys are really good with a grinder. Well, Bruce doesn't want to do it by hand. He made a block of wood with a special angle, and he fastened this grinder on there, and he walked that tool around there and gave us the most symmetrical, very nice weld fit, which Jimmy and Donnie can then turn that weld fit into a whole series of beautiful, high-pressure welds. But look at the smile on him. But that's the rear tube sheet, 9/16 thick. That is one big piece of steel, isn't it, Ted? And here we are, this I took yesterday. We're taking the ramp out, because as I mentioned, we're going to take and jack that engine up in the air. We've got 4 50-ton screw jacks, and we're going to pick that engine up such that we can drop that trailing truck now And we'll have to clear the back part of that trailer truck, and we'll roll that trailer truck out so we can do it. It's our next project. We'll take the wheels out, probably be able to use the axles and the bearings, but I'm going to put new wheels on. And the ramp, these ramps were installed in 1957, went all the way over to here, so we've cut all that out, and eventually we're going to take some more of these ramps out. It makes it really nice to be able to walk around up high and look at the engines, but you can't work on much stuff. So if you've got to work on your steam locomotive, it's got to be on track 4, and you can only work on the north side of it. Take it out, turn it around, and then you can work on the other side of it. So we'll take those ramps out, and we'll be able to work on both sides. And there's the big boy boiler. It won't be long, we'll be putting that front engine back in. Now there's the front engine, as I mentioned. All of these yellow colored lines, that's an insulating material. It's an abrasion resistant Kevlar. In the old days, they had an asbestos type sock sleeve, just like that. So we've replaced it with Kevlar. But there's hundreds of feet of the copper line that I mentioned, just like this, with all these special fittings on there. And it's just a work of art, fitting up each one of these lubricators. I don't believe I've included much of a detailed shot, but you can see the manifold on each side. This would be valve oil, this is engine oil over here. So on the engineer's side, on a big boy, those lubricators were filled with valve oil. On the fireman's side, they were filled with engine oil. And there's the front with a nice new air shield. We had to do a little bit of dental work. Over the years, the pilot had been banged up here and there. And back in the days when the railroad put stuff together, these were utilitarian machines. They welded a piece of steel on there, and they weren't going to quit running it in a few years anyway. So Donnie spent the better part of a day custom fitting 3/4-inch plate and grinding it, making it look real nice up there. This will be a really photographed part of the locomotive, the very front of it. Here's some of the piping. I apologize, it's at an angle. I had to hold my phone to get that just right. And this kind of speaks to why the Challenger needs to be rebuilt. This is on the inside of the locomotive. So all of this pipe on the Challenger is rotted, and it's been replaced with rubber hose. And if you happen to be in Cheyenne the next time you're there and you look at the Challenger, go look at the front end and you'll see this rubber hose coiled up. And it runs it back, and it's plastic zip tied along and runs it back to the second engine. In order to get that fixed, you have to take the front engine out. And here's the new pipe, all brand new. That's heavy wall, Schedule 120 piping. Duplicates each one of those fits. And you got to have a pretty heavy duty pipe bender to make those kind of bends. And there's no other way to do it. If you're going to bend 1 or 2 pipes, get the torch out and have at it and have fun. You'll be frustrated in 10 minutes. You can do it. There's no way we could have bent this pipe with a torch. We'd still be doing it. And this is what it looks like. This is down on the inside. There's no way, you can't even reach in and look, you can't even put your hand in there. There's no way to get to this unless the front engine is apart and the drivers are out. So this is a big shopping job. So that's one of the problems on the good old 3985. It's probably filled all the way up to here with junk, cinders, grease, and who knows what. And because of that, those pipes sit down in there and rot. Especially if you leave it, you sits around with water in it, it gets cold, it rusts, turns into a big mess. Another one of those pipes, angling around and snaking up and around through there. Just a real tedious process. We wanted to make sure and not have any threaded fittings inside, because we'll never be able to get to it. And you know as well as I do, that's the one that's going to be leaking when we go to test this. To pass an inspection, the main reservoir has to pass air pressure test, just like the brake pipe. So do the main reservoir, or excuse me, the brake cylinders. So when we do our main reservoir leakage test, and the main reservoir pipe union down in the middle of the front engine is leaking, what are we going to do? We're going to fail the test. So we've welded all of those pieces together, and then fit them in there and snake it around in there and poke one end up barely enough so you could weld the other end. It was really quite a job. And that's what it looks like. So you've got the brake cylinder pipe poking up out of there. And here's Ted's lubricator. So Ted handmade this piece right up here. It's a strainer, and that's the original one. And he very painstakingly hand-cut, made a small little die to hand-cut each one of those gaskets. These are a heavy-duty cardboard gasket for each one of these pumps. And these are the pumping units themselves. So if you think about how the lubricator works, if you've ever seen a steam locomotive going down the track, you'll see it. This is actuated by the valve here. And each one of those cycles is moving a little ratchet, and there's a frame in there with a little rack with a set of balls moving up and kind of oscillating. And each one of these little pumps moves up, and if you can, when you come up here, you'll be able to get a better look at it. This is called a double pumping unit. There's not very many of these in the lubricator. But this moves upward, and that spring helps return it back up. And as it does, there's a small little slot, and a slot takes a little slurp of oil, and it rotates down, closes the port, and discharges it through a little check valve. And it's all the way down the track, each one of these. A brilliant steam locomotive innovation made by one of the great manufacturers that made steam engine parts. You wouldn't find anything like this in modern industry today. They've got some really good stuff out there, but I'm here to tell you, nothing is made like the way they used to make it back in those days. You look down inside here, and this thing is built like it was inside a Sherman tank. And that's what you want, because there's some very critical things that you're lubricating. The valves in the cylinders, the most critical things in the locomotive. If the valves lack for lubrication, you've got minutes before you've got a huge problem on your hand, and that thing seizes up. Remember that nice new beautiful link I told you about in that eccentric rod? It's going to look like a piece of spaghetti, and it could yank it off the engine and twist it around and slam it into the ballast and bang it up into the boiler, and you can't stop enough, quick enough, when you've got your valve gear falling apart on you. So very, very important piece of the engine. Ted can answer a lot of questions on how he rebuilt it. He did a beautiful job. And here's those other fittings I was telling you about, the beautiful manifolds. There's a lubricator on either side. And on these engines here, you've got a lot of lubrication lines up front, where those big steam lines that are supplying steam to that articulated front part of the engine as it's moving around the corner. All of this is flexible up here. And they did it through an ingenious use of ball joints. And each one of those ball joints is lubricated by a high pressure fitting called a terminal check, receiving its oil from that lubricator. Tremendous amount of lubrication. There's that view I was telling you about. Now look at the beautiful workmanship. Looks like something you'd have in an automobile. But this is original. This isn't something that we came up with. This is how the blueprint shows put this thing together. It's very organized. Each one of these little labels here, as you'll see on that one, actually has a description of where that feed goes to. So when you have a problem, like when we break the locomotive in, we're going to turn the feeds up high. And then over time, we'll just systematically, we'll go through with a chart, and we will start dialing the feeds back as necessary. You don't need to be wasting that oil. But we got to make sure everything is getting the right amount of oil, and that's how we'll do it. This is the underside of the engine. When the drivers are in, you can't get to some of this stuff. This is for the shoes and wedges, and this is that fitting that I was holding up a moment ago, right here. That's why we made these new. Because once they're in, we don't want to have any problems with them. And they're really hard to get to. When we brought the big boy back from California, we cleaned all of this up. Everything that we needed to have working, we got working. So it would be oiling the parts that it needed oil. And we had to get down underneath there on a few occasions and look things over. And I'm here to tell you, there's some places you just can't get to unless you've got a pit. So I'm pretty skinny. I work my way down in there, and you climb yourself or wrap yourself up around an axle, but now what? You can't move your arms. So you want to make sure this stuff is rock solid. This is the front. These are the new steam valves, and this is all the piping that controls the live steam to the air compressor. All done, all put in. Air compressors are installed. And there's that piping as it pops up out of the back and connects to the flexible joints that connect it to the back of the locomotive. A brand new connecting nut on the steam side of an air compressor. This stuff just gets old, and it's just to the point where you just got to make new parts. It's some of the neatest things on one of my satisfying moments is when I walk around the locomotive and see those pieces. And we're just about wrapped up here. This is a big reinforcing joint inside the boiler. And this is a rivet that we have to replace. On some of the rivets on the outside of the boiler, the head popped off for some reason. Over time, they get rust underneath there, and that rust pushes that head, and there was a defect in the rivet, which caused the head to fracture over time, decades sitting out in the park. So what Bruce did is he painstakingly drilled down to the center, and look at that, he got right on it. So he got himself up on a big work platform, and he made this big setup, and he drilled through 5.5 inches of rivet, and he was able to drill through the center of it. So he could get a bigger and bigger drill and continue to drill through there so we could knock that rivet out. This took him one day. 8 hours of work to remove one rivet. If you end up screwing up the sheets, then you're going to have to ream the hole bigger. And as it is, these rivets are as big as we want to drive, trust me. So it's worth the 8 hours of time to get your best guy over there that's going to take his time. And I had to get a picture of it. He came and got me. He said, "Oh, come look at this." And it was just dead through, wasn't it? We like this stuff. And here's some air brake parts. And this concludes this part of the presentation. This is kind of the same stuff we did on the 844, and this is Ted's handiwork. Going through and working on the air brakes and making them as good as new. This good air brake system was developed in the 40s. Actually, it goes a little bit earlier than that. But it is the kind of air brake system that you want to have on a big steam locomotive with a passenger train. When you're running a passenger train, it's different than running a modern train. There's air brake things that you do. There's handling procedures that you do. In our world today, we have what we call fuel conservation. So what I do on a steam locomotive would be considered what we call power braking, where you're pulling a train and you're keeping it stretched and it makes a nice smooth ride for the passengers. Well, then a freight car doesn't understand and doesn't care about being smooth. Well, in order to really manipulate the air brake and to control the air brake, in my judgment, this is the system that we want to have. So just like on the 844, we took that completely apart and we rebuilt it. And Ted did all of that work. Just beautiful workmanship. And there's one more quick picture. What time we have, honey? When? Okay. If everyone's interested, I have a few slides. We moved some equipment from Burnham to the Forney Museum the other day. If everyone's interested, I can go through and show you some of those. Let me move that up to the next piece here.